Hi everyone, and thanks for joining us today. This is Jesse Haworth, Application Engineer with Hawkridge Systems, and in today's video we'll be going over how to use the 3D Texture tool found in SOLIDWORKS Premium to create a physical texture for 3D printing. Now, textures have always had a wide range of aesthetic and practical uses in manufacturing, but they can be both time and cost intensive to implement. One example of this is in the field of injection molding, where texturizing existing molds can be extremely challenging. By leveraging the strengths of 3D printing, we can prototype and implement new textures quickly. To get started with adding a texture to the simple part that we have on screen, we can simply go to our Appearances library, expand Miscellaneous, and then select 3D Textures. SOLIDWORKS has a pre-built library of textures, and for now we'll drag one of the knurled surface textures onto our part. We have the option to apply the texture to the body, the part, a feature, or a single face. For now, we'll apply this texture to a single face. To create physical texture geometry, SOLIDWORKS uses grayscale images. The shape and height of each texture pattern is controlled by the transition between black and white. In grayscale images, white signifies the highest point of the shape, while black represents the lowest surface point. A more gradual color transition between white and black results in a shallower angle from the surface to the highest point of a texture. We'll also be applying a honeycomb texture to this separate face to show how different textures can be manipulated. Now, there are a wide range of grayscale textures available online, but for the purpose of this video we'll be using what's built into SOLIDWORKS. Once a grayscale texture is applied, you can manipulate it by going to your Display Manager, right-clicking that texture, and selecting Edit Appearance. From here, we can go to the Advanced area and select Mapping to change how our texture will look. In the Mapping area, we can edit the texture application on our geometry to better fit different shapes, as well as change its actual location. We can also easily manipulate the texture location, zoom factor, and rotation degree via the on-screen widget. As we do this, note how each value is changing in the Appearance Manager. With the manipulation of this texture complete, we can confirm the changes and start the process of turning this image into a physical texture. Now, to add a texture feature, we can go to Insert, Features, and then 3D Texture. This function can also be accessed via the Mesh Modeling toolbar. With this feature manager open, we'll select our part to start the process of adding textures to it. With the part selected, you can see that a mesh preview of the geometry is created, and that the two grayscale appearances on our part can be selected. We'll select both of these to make sure that they are both included in this single feature. When these textures are selected, you can see that a few different options are now usable. The first one we'll show is the white up, black down toggle. As we talked about earlier, the white color in grayscale textures indicates the highest point of that shape. When this particular toggle is disabled, the color behavior of our images will be reversed, and black will be the highest point in our texture. For now, we'll leave this option as is. Next, there are several different options that will control the quality of our texture. Like all other meshes, textures are made up of facets. The higher that this top refinement slider is set to, the more facets will be used to create each instance of our texture pattern. We'll set this number high to get a better texture, but doing so also uses more resources. We'll set a similar value for our knurled surface by selecting it and changing this slider. The next option here is the Texture Offset Distance, which will control how far the highest point of our texture extends away from the part's surface. You can see here that as we change this for our honeycomb texture, the mesh changes to give us a visual representation of how this might look. As we did with the first refinement setting, we'll set a different value here for the knurl pattern. Last on this list, we have the maximum element size slider, which sets the facet size for the remaining model geometry. A smaller value here will result in a finer mesh, which can create a smoother transition between part and texture. That being said, some parts may not need a very high mesh quality, so this does not always need to be a small value. When we have everything set, we can confirm the feature and navigate back to our feature manager tree. You can see here that the texture is now listed as a feature, and that the process itself created a graphics body of our part. Shaded with edges gives us a little bit of a hidden view, so we'll turn off edges to see our part better. As you can see, our textures have both been physically added, and more can be added or modified as needed. With that quick overview of the 3D texture feature, we'll swap over now to a different example that we'll use for 3D printing. Here we have half of a smooth knife handle, which we want to add some textures to. We aren't looking to add textures to this whole surface, so we've used the splitline function to separate a section of this surface. To add a texture, we'll go back to our library and use a knurled texture, and apply it only to the face that has been created by our splitline. We'll then modify the texture to be a bit smaller and change the location a bit. Once we've confirmed that change, we can go to the 3D texture feature and refine the texture to fit our part. This particular geometry is curved, so we'll increase the quality to have a less faceted result. Once we are happy with the changes, we can add the feature, and the part is now ready to be exported as an STL for 3D printing. If you'd like to take a look at the process and settings used to create an STL specifically for printing, feel free to take a look at our video on the topic by clicking on the link in the description below. We decided to do this process a few more times and print them on a Markforged X7, which is capable of printing layers at 50 microns. As you can see from these pictures, the results are extremely smooth, and each of these files only took a few minutes to texturize. Thanks for watching, everyone, and I hope you found this informative. Please feel free to take a look at some of our other content and contact us if you have any questions.